If we ever meet an alien civilization, it might be the best day in human history. Stephen Hawking believed it was far more likely to be the last one. And in 1974, without waiting to find out which, we introduced ourselves anyway. A group of scientists pointed a radio telescope in Puerto Rico at a distant cluster of stars and sent our DNA, our numbers, and a sketch of the human body straight into the dark, with no way to take it back. So let's ask the question properly. Why hasn't anyone answered? And if they ever do, should we actually be hoping for it? The math, on paper, should embarrass the silence. Our galaxy alone holds somewhere north of 200 billion stars, and current estimates suggest the Milky Way contains at least 100 billion planets, many of them sitting comfortably in the temperature range where liquid water and possibly life could exist. The universe has had roughly 13 billion years to work with. That's enough time for a single technological civilization to spread across an entire galaxy many times over, even moving at a pace we'd consider embarrassingly slow. And yet we look up and we listen, and across every frequency we've ever pointed a telescope at, we get nothing. No signals, no megastructures, no stray radio chatter from somebody else's civilization. Physicist Enrico Fermi put the whole problem in 4 words back in 1950, over lunch with colleagues, when he simply asked, "Where is everybody?" That question now has a name. We call it the Fermi Paradox, and it has never stopped being unsettling, because the silence itself is data. It's telling us something. We just don't yet agree on what. The first, and in some ways the most comforting explanation, is that we're overestimating how easy life actually is. This is often called the rare earth hypothesis, and it suggests that the jump from simple chemistry to something recognizably alive might be a much rarer event than we assume, requiring an almost absurdly specific set of conditions, all lining up at once. Consider everything Earth happens to have that isn't guaranteed anywhere else. A star that's stable rather than prone to violent flares. A moon large enough to stabilize our axial tilt, which, as it happens, we've covered on this channel before, and which gave us the predictable seasons complex life seems to need. A molten iron core, generating a magnetic field that shields the surface from radiation that would otherwise sterilize it. Jupiter, sitting further out, quietly vacuuming up comets and asteroids that would otherwise turn Earth into a shooting gallery. Remove any single one of those, and you may not get complex life at all, or you might get it billions of years later than we did, or in a form too fragile to ever develop technology. If this explanation is correct, the universe isn't full of quiet, hiding civilizations. It's simply full of chemistry that never quite made the leap, on planet after planet after planet, for want of one detail nobody was in a position to arrange. The second explanation is less comforting, and it comes from an economist rather than an astronomer. In 1996, Robin Hansen proposed the idea of a great filter, some improbable step along the path from dead matter to a galaxy-spanning civilization, so unlikely that almost nothing that starts the journey ever finishes it. Here's what makes this idea genuinely uncomfortable, rather than merely academic. Nobody knows whether humanity has already passed its filter, or whether it's still ahead of us. If the filter sits behind us, in the sheer improbability of life forming at all, or of simple cells becoming complex ones, then we've already done the hard part, and our future is comparatively wide open. That's the version of this story you'd want to be living in. If the filter sits ahead of us, the news is considerably worse. It would mean that civilizations reliably reach roughly our level of technological development, and then reliably fail to survive it. Nuclear weapons, engineered pathogens, an artificial intelligence built faster than the wisdom to control it. Philosopher Nick Bostrom put this with a bluntness rare in academic writing, arguing that a total absence of any life at all on Mars found by future missions would actually be good news for humanity, because it would mean the filter is behind us rather than lying in wait. Finding even simple microbes there, by his logic, would be the more frightening discovery, because it would raise the odds that most life gets this far and then doesn't get any further. The third explanation is the one that turns the entire question upside down, and it's the one Hawking himself seemed to take seriously. What if civilizations are common and simply hiding on purpose? The idea, popularized by science fiction author Liu Cixin and known as the dark forest hypothesis, treats the universe less like an empty auditorium and more like a forest at night, one where every hunter is silent for the same reason. Announcing your location to anyone who might be listening is how you get eaten. In this model, every advanced civilization eventually reaches the same grim calculation. You cannot know whether a newly discovered neighbor is friendly. You cannot verify their intentions from 100 light-years away. And if there's even a small chance they see you as a future threat or simply as a competitor for resources, the safest move available to an advanced civilization is to strike first, quietly, before you ever learn they existed at all. Under this theory, the silence of the universe isn't emptiness, it's discipline. Every civilization that survives long enough to understand the stakes learns to stop broadcasting, and the ones that don't learn fast enough simply don't survive to regret it. This is more or less the argument Hawking made explicitly in a 2010 documentary, warning that any civilization advanced enough to detect our signals would almost certainly be advanced enough to do us serious harm, and comparing the risk to what happened when European ships arrived in the Americas, an encounter that, to put it gently, did not go well for the side with the less advanced technology. Carl Sagan spent decades voicing similar reservations before his death, arguing that no single generation had the right to gamble the entire species on a message it couldn't take back. Not every scientist agrees this fear is justified. Some point out that Earth has already been leaking radio and television signals for roughly a century now, a faint bubble expanding outward at the speed of light, which some argue makes the debate somewhat academic. The horse, in this view, left the barn during the Cold War. Others counter that leaked signals are faint and easily missed, while a deliberate, targeted, information-rich broadcast like Arecibo is something else entirely. The difference between a stray whisper and standing up in the dark forest and lighting a flare. Suppose, for the sake of argument, that contact eventually happens, and it goes well. What, biologically speaking, would actually be looking back at us? Almost certainly not the humanoid extras from a science fiction film. Astrobiologist Daniel Apai at the University of Arizona has pointed out that while evolution does sometimes arrive at similar solutions independently on Earth, an intelligent species with 2 arms, 2 legs, and a face at the front is a product of one very specific evolutionary history on one specific planet, and there's no strong reason to expect it twice. There are, however, real physical rules that any alien body would have to obey, because physics doesn't care what planet you're standing on. Surface area to volume ratios put a hard ceiling on how large a warm-blooded creature can get before it cooks in its own body heat, which is roughly why nothing the size of a building has ever walked around breathing air. Bilateral symmetry, a left side mirroring a right, shows up again and again on Earth, simply because it's mechanically efficient for anything that needs to move in a straight line, which suggests it might show up elsewhere too. Where alien life gets genuinely strange isn't necessarily its shape, it's its senses. A creature evolving on a world with no nearby star, or one permanently tidally locked with a night side that never sees daylight, would likely have no reason to develop eyes at all, and might instead sense the electrical signatures of other living things directly, the way certain fish already do in Earth's murky rivers. On a world with a thick, sound-conducting atmosphere, hearing and echolocation might dominate entirely over vision. And in 2017, researchers at Oxford went a step further, arguing in the International Journal of Astrobiology that intelligent alien life, whatever it looks like on the outside, would still be shaped by the same underlying force that shaped us: natural selection, competing for finite resources, favoring whatever survives long enough to reproduce. Their conclusion, more or less, was that aliens might end up considerably more familiar in behavior than in appearance, recognizably driven by the same evolutionary logic, wrapped in a body we might not recognize at all. So where does that leave the question we started with? We genuinely don't know whether the universe is empty, whether we're simply early, whether the hard part is behind us or still waiting up ahead, or whether it's full of civilizations who've already learned, the hard way, to keep the lights off. Every explanation on this list is consistent with the same observation: total silence. That's the uncomfortable part of the Fermi Paradox. The evidence doesn't rule anything out. It just sits there, refusing to pick a side. What I find strangely reassuring about this uncertainty is that it puts a great deal of responsibility back in our own hands, rather than in the hands of something unknowable out there in the dark. If the filter is ahead of us, that's not a prophecy. It's a warning we're still in a position to do something about. And if the universe really is a dark forest, well, we've at least got one advantage every other candidate for extinction never had. Someone already told us the rules before we broke them. The stars keep doing what they've always done: indifferent, patient, and for now, silent. Whether that silence is good news or very bad news probably depends on what we do next. If you want to see what else out there is stranger than it looks, subscribe. Next time, we go past another edge.